All right, welcome back. Today we're going to do key features of rationals and sketching. For this lesson, you definitely want to have your notes with you. You want to have a handy dandy calculator, always just in case. You may not even use it for this lesson, and you want to have the lesson with you. So first things first, we have to remind ourselves what a rational even is. A rational is something that looks like a fraction and has a variable in the denominator, because a fraction like 1/2, that's actually not a rational. I mean, it's a rational number, but not a rational graph. A rational graph or rational equation graph would have a variable in the denominator, and that's what we're going to look at today. So there are a lot of different things that we are going to have to remind ourselves of these, remind ourselves of certain concepts when we're dealing with rationals. So for example, we have to remind ourselves x-intercepts are where the graph crosses or touches the x-axis. Y-intercept, where the graph crosses the y-axis, there can only be one. And there are a couple other things that we're going to talk about as well. So in order to discuss all these things, let's go ahead and let's look at an example here. So I'm going to scroll all the way down to this practice question that says, identify the features of the following rational equation and sketch the graph. So identify the horizontal asymptote is the first one. The second one is removable discontinuities or holes. The third one, vertical asymptotes. The fourth one, x-intercepts. The fifth one, y-intercept. And step 6 to sketch it. So we just have to remind ourselves what these things are. So horizontal asymptotes are invisible horizontal lines that define end behavior. So where the graph is going in the end, that's what end behavior, where is the graph going in the end? Removable discontinuities or holes are just that, they're holes in the graph. So the graph just simply won't exist at that exact point. Vertical asymptotes are invisible vertical lines, I can't spell, don't worry about it. Vertical lines, the graph never crosses or touches. So vertical asymptotes are vertical lines on the graph where as the graph approaches it, it either blows up or it blows down on both sides. So blow up or blow down. The graph will never cross it. It'll never touch it. As it gets closer, it either veers up or it veers down on both sides. So there's 4 ways that a graph can behave at a vertical asymptote. It can both go up, it can both go down, it can go opposite, or it can go opposite the other way. So those are the 4 ways that the graph can behave at a vertical asymptote. X-intercepts are where the graph crosses or touches the x-axis. Y-intercept where the graph crosses the y-axis. Notice you cannot touch a y-intercept and bounce back, because that would make it not a function, because then it wouldn't pass the vertical line test, therefore it would not be a function. So anytime you have a y-intercept, the graph crosses the y-axis there. And then step 5 is to sketch. So what we need to do here is we have to be able to define where each of these things are. So I have my function right down here, and I'm going to use colors to try to help us to identify where each of these things are. So I'm going to do horizontal asymptote. I'll do it first because it's the most complicated one. So the horizontal asymptote, how to find it is by using the degree. So find by degree. Find by the degree. So you want the degree of the top, which is the numerator, and the degree of the bottom, which is the denominator. Now, if we were in class, I would hand this out to you guys. So I recommend, if you can, print this or just write this out onto your notes here. So basically, the degrees help us define where the horizontal asymptote in this graph is going to be. So if the degree of the numerator is bigger than the degree of the denominator, there is no horizontal asymptote. Here's an example. This has a degree of 1. Because it's in standard form, that's the highest exponent, and there's nothing on the bottom, which means the degree of the bottom is 0. So the degree of the top is bigger, therefore no horizontal asymptote. And notice how in this graph, there's no horizontal line where the graph is tending towards. So that is a good example of no degree. If the degree of the numerator is smaller than the degree of the denominator, the horizontal asymptote is always at y equals 0. So here's an example. The degree of the top is 0 because there's no x. The degree of the bottom is 1, so the degree of the bottom is bigger. Notice how in this graph, as it goes far to the left, 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 it's getting closer to y equals 0, and as it goes farther to the right, 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 it's getting closer to 0. So that's a horizontal asymptote of y equals 0. If the degree of the numerator is the same as the degree of the denominator, then you're going to look at the leading coefficients, which are the numbers out front or the numbers in the highest degree term. Usually they'll be out front if it's written correctly, which they should be. So if I notice, this is in standard form, this top here, 6x squared plus 2x, that degree is 2. That wasn't very good. That degree is 2. And I look at my denominator, which is also in standard form. So the highest exponent is the degree, which is 2. Those are both the same degree. The top is the same as the bottom, which means the leading coefficient is the leading coefficients are going to define the horizontal asymptote. So in this case, my horizontal asymptote will be at 6/2, which is the same as 3. And if you notice, there's an invisible line here at 3 that the graph is tending to as it goes to the left, 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 and as it goes to the right, right, right. Notice the graph crosses the horizontal asymptote right there just slightly. That's fine. You can cross or touch a horizontal asymptote. All it defines is the end behavior. Vertical asymptotes, on the other hand, you cannot cross or touch. So you're probably wondering, well, cool, but how do I figure out the degree? Now, if we remember, degree is different if it's in standard form or if it's in factored form. So the degree, if it's in standard form, is the highest exponent. And standard form is where it's like 2x squared plus 7x. So like 6x squared plus 2x, this one we just did. That's standard form. This would be degree of 2. If this were in factored form, so let's do another example. Say it was x plus 3 times x minus 2. This is in factored form where they're written in parentheses, written in factors, okay? This factor has a degree of 1. This factor has a degree of 1. This would be degree of 2, all right? So it depends on what form it's in, if it's in standard or factored. Most of these, you'll have them in factored form, and if they're not in factored form, you're going to want to factor it to get it to factored form. That's the easiest way to find all these key features of rationals. All right, so now let's go back to the example that we're working with, because we want to find the horizontal asymptote because it depends on the degree. So I look at this numerator here. I notice there is no x out front, so I'm not going to count that as a degree. If that had an x there, I would count it towards the degree, but it doesn't. So I just look at this factor, that's a 1. This factor, that's a 1. If there were an exponent there, I would count whatever the exponent is. If they don't have an exponent, it's just a 1. So the degree of this top part is simply 3. Now let's look at the bottom. Degree 1, degree 1, degree 1. The degree of the bottom there is 3. So my degrees are the same, which means my horizontal asymptote, according to my table, is going to be leading coefficient divided by leading coefficient. So I have horizontal asymptote is at y equals 2/1, which is just 2. So there's my horizontal asymptote. All right, let's move on to removable discontinuities or holes. Holes are going to be 0 of the top and bottom. Zeros of the top and bottom. And what I mean by that is a 0 is whatever makes that factor equal 0. Whatever x value makes the factor equal 0. So notice I have x plus 4. Well, what x value is going to make x plus 4 equal 0? Well, isn't it negative 4? Negative 4 plus 4 equals 0. So the 0 of that factor is negative 4. The 0 of this factor is positive 2. Positive 2 minus 2. So here's a little hint, guys. It's always the opposite. So if it says negative 2, it's always going to be positive 2. The 0 is positive 2. The 0 of this factor is negative 1. The 0 of that factor is positive 1. The 0 of this factor is positive 2. The 0 of that factor is negative 2. So holes, removable discontinuity or a hole, in the graph is going to be where the 0 of the top and the bottom are the same. So I notice that I have right here x minus 2 in the top and in the bottom. So that tells me I'm going to have a hole at the 0. So hole at x equals positive 2. So that's my hole. Not every graph is going to have a hole. Just letting you know, okay? So just be aware, if there's nothing shared in the top and the bottom, it just doesn't have a hole. It's no big deal. All right, moving on. Let's use orange, how about? Moving on, identify vertical asymptotes. So vertical asymptotes are zeros of the bottom that are not holes. Zeros of the bottom that are not holes. The reason being is a vertical asymptote is a vertical line where the graph blows up or blows down as it approaches it. Well, what makes a fraction blow up? Having a 0 in the denominator. So anytime you have a 0 in the bottom that's not a hole, that's going to be a vertical asymptote. So I notice that I have one here, and I notice that I have one here. So that tells me I'm going to have vertical asymptotes at, this one is going to be x equals positive 1, and this one is going to be x equals negative 2 because they're at the zeros. So those are my vertical asymptotes. All right, next up, let's use blue. Identify any x-intercepts. So x-intercepts are going to be zeros of the top that are not holes. Those are x-intercepts. Zeros of the top that are not holes. Hopefully this is clear enough for you. If I was doing it on the whiteboard, it would be a little more clear. So zeros of the top that are not holes. So I look here and see why it's so important to do the holes first, because vertical asymptotes and x-intercepts are zeros that are not holes. So you want to make sure you define the holes first. So I see a 0 of the top that's not a hole and another 0 of the top that's not a hole. So that tells me my x-intercepts are going to be at the zeros. X equals negative 4 and x equals negative 1. There are my x-intercepts. All right, identify the y-intercept. So in order to find the y-intercept, let's use purple. The y-intercept, to do that, we are going to set x equal to 0 and solve. So anytime you're on the y-axis, what does your x value equal? Well, it equals 0. So anytime you're on the y-axis, your x value equals 0. That's why to find the y-intercept, you're going to set all those x values equal to 0 and simply solve it out. So I'm going to take my equation. I know you can barely tell what it says, but I'm just going to set x equals to 0. So I have 2 parentheses 0 plus 4. Then I have 0 minus 2, 0 plus 1, all over 0 minus 1, 0 minus 2, 0 plus 2. And I'm just gonna solve this right side. So that will simplify to 2 times 4 times negative 2 times 1 over negative 1 times negative 2 times 2. Okay, 2 times 4 is 8, times negative 2 is negative 16 times 1, so that's negative 16. On the bottom, I have negative 1 times negative 2 is positive 2 times 2 is 4. Negative 16 over 4 is negative 4. So that means my y-intercept is going to be at negative 4. So I know it looks a little crazy, but my next step is to sketch the graph. And in order to sketch it, I want to make sure I've highlighted all these things I've found. So I found the x-intercepts, I found the hole, I found the horizontal asymptote, I found the vertical asymptotes, and I found the y-intercept. So those are all the important pieces of information that I'm going to graph. Now, in order to graph this, I'm going to make an XY coordinate plane. So here's X, here's Y, and I'm gonna do 1, 2, 3, 4, 5, 6, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, 1, 2, 3, 4, 5, 6, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Okay, and I can go ahead and label these, or you can just trust that each one is one unit. All right, so now what I'm gonna do is I'm gonna take all the notes that I found and I'm going to graph them. So the first thing I always graph are the asymptotes. I always do those first. So my horizontal asymptote is at y equals 2. So what I do at y equals 2 is I draw a dotted line, because once again, horizontal asymptotes are invisible lines that the graph tends towards as it goes to the right, 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 and as it goes to the left, left, left. So it's gonna be dotted, okay? Then I have my vertical asymptotes at 1 and negative 2. So I'm gonna do the same thing. I'm gonna draw dotted lines because vertical asymptotes are invisible lines that the graph will either blow up towards or blow down towards from both sides. My other one is at negative 2. So negative 2, my vertical asymptote. All right, then I have a hole at x equals 2. So I'm just gonna write hole here because the hole is gonna be wherever the graph is. I don't know where the graph is yet, so I can't tell where the hole is gonna be, but I put a note there so I don't forget to draw it. All right, next I'm gonna do it doesn't really matter. My y-intercept is at negative 4, so negative 1, 2, 3, 4. So I just draw a dot there saying that the graph has to cross there. My x-intercepts are at x equals negative 4, so 1, 2, 3, 4, and at negative 1, which is right there. So now I have everything sketched out onto my coordinate plane, and I can start drawing what I think this graph is going to look like. Now, the important thing when you're graphing these rationals is there must be graph. I'll do this in a darker color, how about? Must be graph in every section. And I'm gonna put that in parentheses, in every section. And the sections are separated by vertical asymptotes. Okay, so in this example, I have 1, 2, 3 sections. So there must be graph in each of those 3 sections. The sections are only separated by vertical asymptotes, not the horizontal. That one doesn't matter in terms of where the graph, like in the sections, okay? So now I look at each section and I say, what's gonna affect the graph in this section? In this section, it's an end section, which means the horizontal asymptote does matter. The graph has to either come from above it or below it, but pretty close to it. I also have an x-intercept here, which means I either have to touch it and bounce back or I have to cross it. The vertical asymptote also affects the graph in this section because as the graph gets closer to the vertical asymptote, it's either going to blow up or it's going to blow down. So there are three things affecting the graph in this section. Now, if you were in college math, you would need to know exactly where the graph is going to go by using test points. But in my class, I just want you to give me an example of something that could potentially work in this section. So here's an example of what I'm talking about. The graph could come from here. It could touch the intersect, and then it could bounce back up and go up. That's totally valid. It's legal. It meets all three requirements. That could be a possibility. It could also come from the graph or come from the horizontal asymptote, cross, and then go down that way. That's another option. Now, normally you would use number line or you would use test points, like figure out what the graph equals at -3 and see if it's positive, it means it bounced back up. If it's negative, it means it went down. But like I said, all I care about is that you did something that matches. So I'm gonna leave that one. Now let's go to the middle section. The things affecting the graph in the middle section are this horizontal asymptote. I know the graph has to come from above from the asymptote or come from below from the asymptote. I also know the graph has to cross or touch at this x-intercept. I also know the graph has to cross at this y-intercept. And then I know the graph at this asymptote has to either go down or go up, okay? So the thing about it is I know from here the graph cannot go up. Why? Because there's no x-intercept there. So I know from here the graph has to go down no matter what because there's no x-intercept here. So now I just have to decide, is the graph gonna come up and touch this and then come back down? Or is it gonna come up and cross and go up? I'm just gonna do that one. I'm not sure which one it is, but I know that that's legal. And remember, you can cross horizontal asymptotes. It's only the vertical ones you cannot cross. So that's an example of what it could potentially be. Now let's look at the last section. What's going to affect the graph in this last section? Well, first I have this vertical asymptote. So the graph either is going to come from up here or it's going to come from down here. Then I also have the horizontal asymptote, which means the graph has to end up getting closer and closer to this line as it goes to the right. So there's really only one option here because there's no x-intercept, which means I can't come from the bottom and then come up over there. So the graph has to come from the top and then meet the asymptote there. Now remember, the last thing is I have a hole at 2. So I go to the x equals 2, wherever the graph is there, and I draw a hole. And that's it. So that's how we graphed our rational. Let's scroll, and it looks like we got what they got as well. Now, if we would have done the other option where we could bounce up there, that would have been fine for me, for grading wise, but it is nice when you kind of guess the right one. All right, so hopefully that helps you with your quiz for this lesson. The next lesson or the next video will be showing you going over the assignment. So hopefully that will help even more. If you have any questions, go ahead, rewind, take pictures, draw stuff out, whatever you need to do, or just ask me. Hope you're having a great day.